This diagram is labeled cardiac cycle components. The reason for this diagram is because there's so many test questions that test this exact thing. So let's go through it. What you want to do is you want to be able to match the things that happen on here on the flow volume loop or the pressure volume loop. And this is confusing, and the reason why this is such a good test question is because time is represented on here. This is from the Wiggers diagram, and then this is the pressure volume loop. Okay, so we have a lot of events happening on the Wiggers diagram. We have the mitral valve closes, the aortic valve opens, the aortic valve closes, the mitral valve opens. Okay, so again, there's no time on here. This is the left ventricle. That's what we're talking about. And so let's start with just a point here. I'll start with mitral valve closes. Okay, when does the mitral valve close? It closes when the left ventricular pressure, when the left ventricular pressure becomes greater than the left atrial pressure. Okay, and where does that take place? It's right here. Okay, and what's that called? It's called end diastolic volume. What else can you call it? You can call it end diastolic pressure. Preload. You can call it preload, and actually you should call it preload because that's usually what it's called. So anyway, so that's when the mitral valve closes is right here. Okay, and what happens next? We have isovolumic contraction. Again, this is volume here. I've got volume written out this time, and so the volume is not changing. We're going up. We're going up in pressure, and the pressure is going up until it can open that aortic valve. And so the aortic valve opens here on the Wiggers diagram. It opens right here on the pressure volume loop, and that is called afterload. There are exceptions to that. You could also call this diastolic pressure. There are exceptions to that. In general, though, this right here is going to be afterload. After that, we have ejection. So ejection is taking place here on the Wiggers diagram. Ejection is taking place here on the flow volume loop. And that's where it gets tricky, okay? Because we're going in this direction now on this diagram, and we're still going in this direction on this diagram because remember, this is time. Time always goes forward. We can't slow down or stop time. So, and there is no time on the pressure volume loop. Again, the time component on the pressure volume loop is, if there is one, is that when we go around this loop one time, that's one heartbeat. So if somebody's heart's beating 60 beats per minute, then going around this would be 1 second. If somebody's heart is beating at 120 beats per minute, it takes a half a second to go around this. But there is really no time illustrated on here. And these are not time questions that are going to be asked about the pressure volume loop. So we eject, we get to this point here, and again, what is that called? This is a really important term that gets tested a lot. It's peak isovolumic pressure. Remember, isovolumic, the volume's not changing. There are two places on here where the volume's not changing. From here to here is isovolumic. From here to here is also isovolumic. Where's the peak? It's right here. It's always right here when the left ventricle closes. So, and you can draw a line like this, and that line represents contractility. So as long as contractility does not change, the end systolic volume, so where's end systolic volume? This is a trick question. It's right here, okay? This is end systolic volume because the stroke is from here to here. So this is the end of systole. And systole has ended. The valve has closed. That's where we are here, is the aortic valve has closed. And we're isovolumic. It's relaxing. This is end systolic volume right there, okay? And then when does this take place, the mitral valve opening? It takes place right here. And the reason why, again, as you can see on the Wiggers diagram, the pressure in the left ventricle has now gone so low that it's below the left atrial pressure. And so we have the atria pushing blood into the left ventricle. So hopefully that makes sense.